In this question, we are required to show the numbers in a Venn diagram that's given. Now, one thing that you have to remember is that what's given here represents the number of elements under consideration. So these are the number of elements under consideration. So that means that the rectangle here represents 50 elements. And what is common between A and B is 4 elements. So the number of common elements, this is the number of common elements. And they are 4 of them. So basically we can put here, but remember the numbers that you're writing in the Venn diagram here are not elements. They represent the number of elements. Okay, so in the middle we have 4. Now, if in the middle we have 4 and the number of elements in A are 5, then just A will be 5 minus 4, which will be 1. So just A will be 1. To make, of course, 1 plus 4 gives us 5, and that's what's required here. And then the same thing applies to just B. So just B will be 9 minus what's common between A and B, which gives us 5. So just B will be 5 elements. And then outside, to get what is represented by what's left outside, the number of elements outside, that will be the total number of elements considered, which are 50, minus what is in each of these. Yeah, so just A is 1, common between A and B is 4, just B is 5, and if you work this out, this same as 50 minus 10, which will be equal to 40. Okay, so these will be 40 elements. All right, so we can use that to answer this question. So the first question is find the number of elements that are just in A. This means just in A. Just in A. Yeah. Or you can say A but not B, which implies just A. So just A here will be just one element. And then here we have A or not B. So remember, the union here means combining. So we are combining the number of elements in A and not B. So combine the number of elements in A and not B. So the number of elements in A will be equal to 1 plus 4. And then not B, of course, not B will be outside this circle. We have 1, but you've already written 1. Yeah. And we have 40. So we have 40 here. So the total number of elements, if you combine A and what is in A and what's outside B, that will be equal to 45. That's your final answer. Okay, number 11. Again, here we have the numbers of elements that have been considered, which are 36. The number of elements in B, 21. The number of elements that are common between A and B are 8. So I'll just start with that. So that's 8. And then just B will be 21. This side, just B will be 21 minus 8, which will be equal to 13. And then we have this condition here, the number of elements outside A. So outside A will be this plus that. So outside A will be this plus that, which implies that this, the number of elements outside the two circles, will be 18 minus 13, which will be equal to 5. All right, so but we know that the total number of elements are equal to the total number of elements are equal to 36. So which means that just A will be equal to total number of elements, which is 36, plus each of this, because we know that this plus that plus that plus that should be equal to 36. So that will be 8 plus 13 plus 5. So if you work that out, that should be equal to 10, and that will be the number of elements in just A. So once you have that, those number of elements, we can move ahead and answer this question. So find the number of elements in A and B combined. So we combine the number of elements in A and B. So which means the number of elements in the two circles. So that will be equal to 10 plus 8 plus 13, which will be equal to 31. And then here, this means just A. Yeah, the number of elements just in A, which will be equal to 10. I just talked about that. So A but not B, which implies just A, and that will be just 10. Okay. So number 12. In number 12, we have been given these conditions that A and B do not have anything in common. So basically, A and B have nothing in common. That's what it means by, what's common between A and B is nothing. It's an empty set. It doesn't have nothing in common. So we can sketch B there. So that's the set representing B such that A and B have nothing in common. And then C is a subset of A. So which means that the elements in C are also in A. That implies that we can, draw C inside A, because we know that the elements in C are also in A. And then the second part of the question is on the Venn diagram, share the region representing what is in A but not C. So just A, or A but not C. So A but not C will basically be A but not C will basically be that. Yeah. So A but not C will basically be what is in A but not C. Yeah. So A but not C will be represented by that.